Okay. Hi friends. Today my topic is on programmable logic controller. Today we are going to deal with what is meant by PLC, what is the configuration of PLC and architecture of PLC and some introduction to basic ladder programming. Okay. Now, what is a PLC? Now see, basically a PLC means it is a programmable logic controller. Okay. Now, it is a specialized controller to control machines and processes. Okay. Now, it is the major advantage of using PLC is it is basically industry compatible. Okay. Now, the major functions of PLC are, first one is timing, second one counting, third one sequencing, fourth one arithmetic and data handling, and fifth one is on-off control. Okay. Now, basically PLC means it is an assembly of solid state elements. Okay. Now, according to the program which you have written, it makes logical decisions and provides the required outputs. Okay. Now, coming to the definition of PLC. Okay. According to National Electrical Manufacturing Association, the PLC definition can be read out as a digitally operating electronic apparatus which uses a programmable memory for the internal storage of instructions by implementing sequencing, timing, counting, and arithmetic to control through digital or analog input-output modules, various types of machines or processes. Okay. Now, the excluded one are drum and other mechanical sequencing controllers are excluded in this domain. Okay, that is a basic definition given by National Electrical Manufacturing Association. Right. Okay. So coming to the parts of PLC. Okay, PLC basically consists of input module, output module, power supply, CPU, and programming device. Okay. Basically, generally, in any mathematical expressions or any industrial processes, you can write output as a function of input. Okay. Now, where this function comes from? Function is basically the program which we are doing. Okay. Now, that program is stored in the CPU memory area. Then data means which are the inputs and to which outputs we have to give the corresponding output. Okay. Now, programming device is the device which is used for programming PLC. It can be a computer, it can be a stylus or something like that. Now, input module is where we are attaching the inputs. Okay. Here we have NO switch, NC switch, then and variable switches. Variable switches means this is normally open and normally closed switch. Now, output can be either it can be a heating element, it can be a motor, it can be bulb or a heater, anything. Okay. Now, the power supply is common to input module, output module, as well as programming device. Okay. The power supply can be 240 volt AC or 24 volt DC. Okay. Now, generally in all other type of controllers, input and output is not shielded from the CPU. Here, the shielding of the CPU is given using an optical isolation. Optical isolation means basically here input modules, when the input comes, it is basically an LED isolation. Okay. So corresponding to the LED which is blinking in the input module, the CPU gives the output. Okay. Similarly, optical isolation is given between output module and CPU also, which gives a shielding of CPU. Okay. That means if any problem happens in any of the part, you can remove any part and CPU will be safe. Go into the next slide. Okay. Now, this is a basic industrial view of a PLC. Okay, you can have inputs as push buttons, outputs can be a contactor connected to a motor, or it can be a lamp, or it can be a three-phase motor, or it can be fans, anything. Okay. Now, coming to the basic architecture of PLC. Okay. Now, the data is taken from the real world. Output, that means input is taken from the real world. Output also should be given to the real world. Okay. Now, there are three buses connecting input, output, memory and CPU, which are address bus, data bus and control bus. Okay. These buses interconnect between input, output, memory and CPU. Okay. Address bus gives addresses for input and output as well as memory. Data bus is used to transfer whatever is the existing data in the input to the memory and give the data and give the processed data back to the output. Control bus is used to control these inputs and outputs. Okay. Now coming to parts of a PLC pack, it consists of input module, output module, power supply, CPU and programming device. Okay. Now what is input? Now first I am going to discuss about input modules and output modules. Okay. Now to incorporate this input and output modules, there are two ways of incorporation. First one is fixed input output. Second one is modular input output. Okay. The fixed one is known as single board or open frame, and modular input output is also known as Shorak type. Now, in the case of fixed I/O, in the case of fixed input output unit, basically there will be a unit. Okay. Input output interface will be in a single element. Okay. The inputs, processor and outputs, it cannot be separated. It comes as a single module. Okay. It comes as a single package. That means you can connect the inputs, connect the outputs. Okay. But you cannot split this split input module, split output module separately. It comes in a single pack. Okay. Now here in the case of fixed IOs, there is no removable outputs. Processor and IO are packed together. IO terminals are available, but it cannot be changed. It is fixed. The number of input and output terminals is fixed. Okay. Now this type of packaging has low cost. Why? There is only one module which is embedding all these input module, processor and output module. Okay. Now if you want to increase the number of inputs and outputs, you need to add additional units. Okay. Now that is lack of flexibility. If any part of the unit fails, the entire unit has to be replaced. That is a major disadvantage of using fixed IO. That means if one of the input fails, in the case of a fixed IO PLC, what happens is that you have to buy the entire module, including the processor input module as well as output module. Now coming to modular type IO. Modular type IO means input module is separate, processor part is separate, output module is separate, power supply is separate, as well as programming device is separate. Okay. That means here what we can do is you can increase or decrease the number of input modules as well as output modules. Okay. Or also you can replace each input and output modules and output modules separately. Okay. Now here in the case of modular IO, power supply is one module, this processor module is another module, output module is another module. That means you can separate it out, each one separately. Okay. Now this is basically modular IO. That means here each modules can be slided into a rack. These racks are interconnected on the back. Okay. These racks are interconnected on the rack. Okay. That rack in which it is arranged is known as back plane. It is known as back plane. Now in the case of, this is what I have explained right now. It is divided into it is divided by compartments which is easily removable. Okay. It is basically in the form of a shoe rack. The major advantage is that it has increased flexibility. Now it consists of rack, power supply, IO modules and operator interface. Okay. Now now that means since this is a shoe rack type arrangement, each module can be slid into the rack, and the interconnection is made using a backplane. Okay. The PLC connector on the backplane communicates with all modules. That means backplane acts as the connector between input module, output module, and input module, output module, as well as the power supply. Now power supply, as I have mentioned, in the case of any type of PLC, we can have a 240 volt AC power supply or 24 volt DC power supply. Okay. Now it can be modulated based on the manufacturer's application. Okay. Now it is capable of delivering the required power. Okay. If power supply is a separate module, then it is capable of delivering a current which is greater than the sum of currents of other modules. If a system is large, power to field devices is given from external AC or DC power supply. Okay. That means you can increase or decrease the power supply as per the requirement. Now, power supply means it can be either DC power or AC power. Okay. This power supply, it can act as a separate unit. Whereas in fixed I/O, that power supply is embedded into the single module. Okay. Now coming to the main part of the PLC. The main part of the PLC is CPU. Okay. What is a processor? The processor is where the programming is done. Okay. The programming is done based on the data given. Okay. Now it is basically the brain of the PLC. Okay. Processor is where we are doing the programming. Okay. Now coming to the programming unit. This programming unit is where it is a user interface. It is basically the user interface. It can be a computer system. It can be any a stylus type thing, or it can be a module, anything. Okay. So here what we can do is the logic can be given by the user. Okay. Now this programming device needs to be interfaced with the PLC. This interface is basically known as Industrial Ethernet or RS485. Okay. This RS485 rather than RS232. Okay. Now programming device, this is what I have told. The interface between the programming device and PLC. This one should be basically RS485, or it is known as Industrial Ethernet. Okay. Now coming to advantages of using PLC. Okay. First advantage is that in the earlier days we were using relays. Okay. Here that relay things, everything is avoided. Okay. That whatever we are doing with the help of a relay, that is made into a program with the help of a PLC. Okay. So it eliminates the hard wiring that is associated with conventional relay circuits. Okay. Here what happens is that in the case of earlier things, you need an overload. For example, if there is any overload happening, you need an overload relay. If there is a short circuit happening, you need a short circuit relay. Okay. So here in this case we have input modules, and that means inputs connected to the input modules, output connected to the output modules. Only that much wiring is required. Okay. No need of any relays in between. You can directly connect the input to the input module and outputs to the output module. Okay. And whatever we are doing with the help of a relay is done inside the PLC, inside the processor of the PLC. Now, increased reliability. That means once a program has been written and tested, it can be downloaded to other PLCs. That means the same program can be applied to different types of PLCs. That means, for example, in the case of the major PLC manufacturers in the market are Siemens, ABB, Yokogawa, etc. If you are having a single program, it can be easily rewritten. In the same format to all these three kinds of to any kind of PLCs. Okay, I have mentioned the best three. That is Siemens, ABB, as well as Yokogawa. Okay. Now it is having more flexibility. More flexibility means if the same program fits to to more than one application, then what you can do it as you can use it as a plug and play device. Your PLC can be used as a plug and play device. That means, for example, in the case of a wood cutting machine, the only function you need to have is rotate a motor according to the rotary pulse. The same thing can be used to adjust the speed of a fan. Okay. So for these two purposes, we can have the same programming. Okay. So that is a major advantage of using PLC. Now, next one is communication capability. A PLC can communicate with other controllers or other computer equipments very easily. Okay, that is via industrial Ethernet cables. That is using RS 485 cables. This PLC will be able to communicate between other programming devices or even other PLCs. That is a major advantage of using a PLC. That is, suppose if you are having a say 100 inputs and 1000 outputs, say one PLC is able to handle 25. The other one is able to handle 25. Okay, that means you can have 25 inputs to one PLC, another 25 inputs to other PLC. Also, another thing is that one PLC can act as a master and other one act as a slave. Or using one PLC you can program other PLC, or you can take the input and output of the other PLC. Okay, such type of system is known as supervisory control and data acquisition. That is known as SCADA. Okay. Now, coming to another advantage is it is compared to other controllers which is used in industry. PLC has faster response time. Okay. Now, in the case of generally PLCs can be classified into classified based on the memory. Okay. Now, if memory is more, then it have faster response time. If memory is comparatively less, it has less response time. Okay. Generally, in the case of all PLCs, the response time is almost less than 10 milliseconds. Okay. Now, another advantage of using PLC is it is easier to troubleshoot. Easier to troubleshoot means, see, here we are doing programming only. Inputs are converted to the input module, then based on the program, outputs are given. Okay. That means if there is any connection mistake, then it is very easy to find. Okay. That means if there is any connection mistake in connection number 1 or connection number 10, and output is not showing based on the logic, then we can easily analyze which input has not come. Okay. Now, a basic comparison between the old relay-based control and PLC-based control. In PLC-based control, hardwiring is less, whereas in relay-based control, everything is hardwired. Now, if you need to have two purposes, only thing is in PLC only program needs to be changed, whereas in relay-based, the entire wiring has to be changed. Now, coming to the expense part, PLC-based control is comparatively expensive and relay-based control is less expensive. But nowadays it is coming in the ulta way. That means PLC control is becoming less expensive than relay-based control. Okay. Now, size is small in the case of PLC, whereas the entire size is large in the case of relay-based control. Now, in PLC-based control, it is used for control applications, whereas in relay-based control, it is basically used for protection. In PLC-based, the major advantage is it is reliable, whereas relay control is less reliable because we need to control so many relays for one purpose. Now, PLC-based control is virtually self-documenting. That means you can that data is stored virtually in a space which is self-documenting, whereas relay-based control is not self-documenting. Now, PLC-based control, the operation is based on a digital system. That means even if the input is analog type, it is converted to digital. Okay. Whereas relay-based control is operating entirely on analog system. Okay. Now, PLC-based control is basically a digital microcontroller, whereas relay-based control is basically an analog. It is based on analog components. Okay. Now, here serial execution is there. In the case of PLC-based control, execution is serial. That means line by line. Whereas in relay-based, it is parallel execution. Now, a comparison between PLC and PC. Now see, in the case of a PC, you have a screen, keyboard, everything. Whereas PLC will not have is not having screen or keyboard. It only has a processor and input-output module. That means it is in PLC, it is capable of operating in industrial environment. It is programmed in relay ladder logic. Okay, it has no keyboard, CD drive, monitor, or disk drive. And it has communication ports and terminals for input and output devices. Okay. Whereas PC can be used only for programming. Okay. Now, coming to the operating cycle of a PLC. The operating cycle of a PLC is basically, first you have to scan. Say there are 10 inputs and it should be given to 100 outputs. Okay. First you have to scan which are the inputs, which are the outputs. Okay. First inputs and outputs are scanned, then logic is scanned. Okay. That logic is fed to the output. Okay. Again, this cycle continues. Okay. The completion of one cycle of this sequence is known as scan. The time taken for one complete operating cycle is known as scan time. Okay. So you have two definitions here. One is program scan and one is scan time. Program scan one is scan. Scan means you have first you have to scan the inputs and outputs. Then logic should be scanned. Then it should be again fed back to inputs and outputs. Okay. So the time required to scan is known as scan time. In the case of Siemens PLC or ABB PLC or even Yokogawa PLC, the scan time is less than 10 milliseconds. This is what I have mentioned as, I have mentioned the advantage as faster response time. Now, coming to the explanation of this PLC scan cycle. First, in the first phase, inputs and outputs are read. In the second phase, program is executed. In the third phase, that is diagnostic and communication. If there is any problem, that means diagnostic means we have to scan the input, we have to scan the outputs. Okay. If the outputs are not ready, we have to again scan the program. Okay. That comes in diagnostics and communication means we have to communicate between input to the PLC and then PLC to the output. Okay. That happens in phase 3. In phase 4, you have output scan. That means outputs are scanned and the corresponding outputs are given to the corresponding outputs. Okay. Now here, now see, in the case of any PLC, you have three things while programming. One is input, one is output, and third one is memory. Okay. So each input have a memory, have a address. Each output have a address, as well as each memory have a address. Okay. So whatever program is given, depending on the input address and output address, this PLC programming cycle will operate. Okay. So that is about the different phases. Okay. Phase 1. A PLC scan cycle begins with the CPU reading the status of inputs. Phase 2. The application program is executed using status of the inputs. Phase 3 is this one, logic to solve or program execution. That is what I have mentioned in diagnostics and communication. Then phase 4, output status scan. An output status scan is then performed whereby the stored output values are sent to the actuators and to the output devices. If the output is not ready, again the program will be scanned and the corresponding output will be given to the output address, which triggers the output. Now, that was an introduction about the architecture of PLC and parts of PLC. Now coming to the programming part of PLC. Now there are different methods of programming PLC. Here I am explaining only one. Okay. Here what I am explaining is about the ladder diagram. Okay. Now, what is basically a ladder diagram? It is one of the primary programming languages of PLC. The other programming languages are, you can use functional block diagram, structured test, instruction list, sequential function charts, etc. But the most easiest one is by using the ladder diagram. Okay. Now, basically a ladder diagram is a visual and graphical language. Okay. In comparison with high-level languages such as C, C++, and Java, ladder diagram is basically a visual and graphical language. Okay. So no need to code it. Okay. Now it is basically derived from relay logic diagrams. Okay. Now basically to explain about ladder diagram, we need to the basic ones are and, or, and not. Okay. Stop. Okay. Yeah, okay. So to have a introduction to ladder diagram, okay. Ladder diagram basically consists of rails and rungs, okay. Rails are where we are giving the supply. Suppose if you are, now rails means on one end you have 120 volt and other one will be the neutral. Or or if you are having a DC supply, one will be positive end, the other will be negative end. Now, the program is basically run is basically written in rungs. Okay. Now, each rung will have inputs and output part. Okay. Whatever is written to the left is input and whatever is written to the right is output. Okay. So it is basically now generally a ladder diagram is a combination of rail, rung, inputs and outputs. These inputs and outputs are on rungs. Okay. Now, basically, there are two types. Now, while scanning the program using a PLC, there are two types of scanning. First one is horizontal scanning and second one is vertical scanning. In the case of horizontal scanning, each rung by rung is scanned. That means after the first rung, coming to the first point of the second rung, it is scanned. Then coming to the first point of the third rung, it is scanned. Okay. So here, rung by rung scanning is known as horizontal scanning. Whereas in the case of vertical scanning, all the inputs are scanned first. Then depending on the logic, it is given to all the outputs. That is the difference between horizontal scanning and vertical scanning. Okay. Normally, for safety purposes, in all PLCs, we go for horizontal scanning. Okay. If the purpose is very less, then only we will go for vertical scanning. Okay. Siemens PLCs or ABB PLCs or Yokogawa PLCs use horizontal type of scanning. That means for that the scan time is 10 milliseconds. The scan time is 10 milliseconds, which I have already explained. Okay. So I think you have got the structure of a ladder diagram. Now, the basic of a ladder diagram is NO switch along with light and NC switch along with light. Okay. NO switch means it is normally open switch. It is normally open. It is a normally open switch. It is known as NO switch. Okay. In the case of a normally open switch, if you look into the diagram of a normally open switch, what I mean is that initially the switch will be open. Whenever the switch is pressed, then only light will be glowing. Now, if I am converting this to a PLC program, okay, here S1 is NO switch, L1 is light. Now, this is the symbol of a NO switch. That is symbol of a NO switch. That stands for light. Light is output. It can be a motor, it can be a fan or anything. Okay. Now coming to NC switch. Okay. NC switch means it is normally closed. Normally closed means this is the switch. This is a normally closed switch. Now, in the case of a normally closed switch, what happens is that if we are not pressing the switch, if the switch is not pressed, then light will be on. When the switch is pressed, then light will be off. Okay, so NC switch is represented by a cross along with the NO switch. Okay, that means here what happens is that when the switch is pressed, light will be off. Otherwise, light will be on. Okay. Now, if you are having so these two are the basics of NO switch and NC switch. Now coming to AND logic. Coming to AND logic means suppose the question is like this. If S1 and S2 is on, then only light is on. If that is a question, what to do is S1 and S2 should be connected in series. Then only light will be glowing. That means if S1 is on as well as S2 is on, then only light will be glowing. Here I am using endo contacts. Okay. So if you are drawing the diagram for that, if S1 is on as well as S2 is on, then only light L will be glowing. Okay. Now coming to the OR logic. In the case of OR logic, what happens? If any one of the switch is getting on, light L is getting on. Okay. If you are drawing the diagram, if S1 or S2 is on, then light will be on. If S1 or S2 is on, then light will be on. Now, the most contradictory one is about NOT logic. The most contradictory one is about NOT logic. Okay. Now, actually, if you are seeing to the graph of NOT logic, it is like this. If you are having input and output, if input is 1, output is 0. If input is 0, then output is 1. Okay. That is, here what we are, here what we are going to do is, we are using an NC switch. Okay. That means here NC switch means it is a normally closed switch. Okay. It is a normally closed switch. Normally closed switch means even if we are not pressing it, then output is high. That means here actually the initial input is 0. We are not pressing it. Once if you are pressing it, the input becomes 1. Once it is pressed, the light becomes off. Okay. That is a basic example of a NOT switch. Or what I can say is that NO switch is a NOT combination of NC switch, and in the vice versa way. Okay. So with that, I am concluding my lecture on introduction to PLC, parts of a PLC. Then I have mentioned about the architecture of a PLC. Then I have introduced to you the basic ladder diagram concept of a PLC. Okay. Thank you and welcome.